Hello, everyone. So yes, my name is Bjørn. I will be talking about birth-death congruence classes can be collapsed using Bayesian shrinkage priors. So first, let me just quickly set the stage. So what are we interested in? I'm interested in inferring diversification rates from trees. And quickly, how do we do this? We use a birth-death model. And here I will show a cartoon of a simulation based on a birth-death model. So in blue, we have a speciation event. Time is going from the left to the right. In the next time step, we have 3 speciation events, more lineages. In the new time step, we have 2 extinction events in red and 1 speciation event in blue. Now, the true tree is not typically something we can observe. We don't see extinction events. And usually trees are estimated based on extant taxa. And we get, without this information of the extinction events, we get to see the so-called reconstructed tree. And from the reconstructed tree, we would like to infer speciation and extinction rates of the past, something along the lines of this curve. Now, last year, there was posited a problem in the literature by Luca and Pennell. In Nature, they showed that there exist so-called families of diversification models, so-called congruent models. And here I show an example of those. We can set up some model, and they provided equations and set up very nicely for how you can construct alternative models. Let's put up 2 more congruent models with higher rates. We can generate infinitely many of these with lower rates as well. And the problem with these models is that they have the same likelihood when you evaluate on any dataset. And when you sample trees from these, they produce the same reconstructed trees. So the question is, can we use statistics to pick out one of these models out of many if the problem is not identifiable? And our proposed solution is to use a Bayesian skyline model. It is a piecewise constant model of rates through time. And we use a trick called temporal smoothing. This is a framework in which we favor smaller changes over larger changes, a sort of Occam's razor principle, where we prefer a constant rate model over others. So the question is, can we solve the problem using appropriate priors? And how do we test this? We set up 3 different scenarios in a simulation study, where I set up one model. So these are in the same congruence class, the same likelihood. One model has constant rates, one has increasing speciation rate, and one has decreasing speciation rate. We can see that they have equations for the speciation rates. They look a bit funny, but in the top right, you see the rates and how they look visually. And in all cases, the extinction rates are constant. We simulated 100 trees based on these models, and we tried to infer the rates back using our Bayesian skyline model. If we look at the results, we can see that the top panel has the constant rate model, the middle has the decreasing speciation rate model, and the bottom has the increasing speciation rate model. We do recover the constant rate model, but we do not recover the increasing and decreasing speciation rate model. The problem is still not identifiable, but we did not recover the true model in 2 of the cases, but we did recover the simplest model. If you want to ask more questions to me later, please see the poster. I believe it is number 13. Thanks to Andy McGee for helping out, and everyone in the HONA lab. Sebastian Ho is my supervisor. I believe others will have posters as well, and thanks to the funding.